Today we're talking about chapter 5.5 for Algebra 1, and today it's involving absolute values. It's inequalities with absolute value. If I asked you guys the absolute value of 5, you say?
5.
If I asked you the absolute value of negative 3? 3. What is actually going on? Making it positive. Why? Because what is absolute value?
It's the distance from the number between 0.
Yes, she did raise her hand. And so now that's on the video of me yelling at you to not answer when you're not called on. So, Emma was correct when she said it's the distance from your number to 0. And here's the problem, guys, is that when we had an equal sign, there always seemed to be two answers. Because when I asked you guys what's the absolute value of some number equaling 2, there were two answers to this, yes?
Negative 2 and 2.
Negative 2 and 2. Two different points on the number line are the exact same distance away from 0. One positive way, one the other way, the negative direction. So, that's great. There always seemed, or not always, there could be a chance there's only one answer, or none. But most of the time there was two answers. But now we're talking about inequalities, and inequalities end up having multiple answers, right? Like, when is x greater than 3? 4, 5, 6, 7, all of those things. So there's multiple answers, actually an infinite amount of answers for that particular problem. But now what we're going to do is we're going to say, hey, what happens when I take the absolute value of a number? When is that greater than 3? What kind of values? 4. Can I take the absolute value of 4 and be bigger than 3? What's the absolute value of 4? 4. Is 4 greater than 3?
Yep.
Yes, that works. 5?
Yep.
6?
Yep.
Yeah.
Negative 2.
No.
The absolute value of negative 2 is 2. That's not bigger than 3. What about negative 4, though?
Yep.
Yes, because absolute value of negative 4 is 4, and 4 is now bigger than 3. So, wait a minute. There seems to be multiple answers, but there's also a spot or places where there are no answers on the number line. And so we need to take a two-case approach to this. The two cases are case 1 and case 2, and those are a less than symbol, or less than or equal to, or a greater than or equal to 2. That's the two cases. Which way is the inequality sign facing? Greater than or less than? This maybe shouldn't say the two cases. This should be the solving the two cases, maybe. So we are going to solve the two cases. And the cool thing about it is you treat them both the same way. It's just that if you notice, there's a different word between them. There's the and, which means intersection, right, where they overlap. And or is the union, which means all of the values that they have. Taking a little bit of everything, right? Taking a lot. So, here's the cool thing. In both cases, you can see you're going to have an absolute value of something, in this case, x minus a. Absolute value of x minus a. And we are going to be less than or equal to c for this case. To solve the problem, steps 1 and 2 both give you half of the solution. So in step 1, it says just drop the absolute values. Guys, I cannot solve an absolute value equation without getting rid of the absolute values. I just don't like them. I can solve it algebraically without. And so, what I say is, just take them away. Just drop them. So now you have x minus a is less than or equal to c. That alone will give you half of the answer. But it's only half. We then go to 2 and say, you drop the absolute values again. See, they're gone. X minus A. But now I'm going to take the opposite of C. And I kind of act like, hey, if I'm going to multiply something by -1, what should I do? Flip the inequality. So therefore, you keep the stuff that's inside, X minus A, switch the sign, and make it equal, or the C value, opposite value. Flip the sign, opposite C. This will give you both sides, or both cases, that make it true. And here's the thing. Because it's a less than problem, it's an and. You're looking for where these things overlap. And since it's a less than problem, I can write it as a single compound inequality. But again, if I cover up this stuff, X minus A is less than or equal to C. Isn't that just the first part? And then if I cover up the last part here, X minus A is greater than or equal to C, negative C. That's this one. So if I can sandwich those together, I can write a single compound inequality. This only works for the less than sign. So that means the absolute value is first, and it's less than something. Okay? Now, going to the bottom, we could change to case 2 where we have a greater than or equal to. It doesn't matter. Again, drop the absolute values. I have half the problem. Or, this one's or now. It's this or that. I drop the absolute values, set it equal to, or set it to the opposite of C, but then flip the sign. So, what are the rules? You can drop the absolute values, leave it as is. Drop the absolute value, take the opposite of C, and flip the inequalities. Solve them out. Separately, put them on the same number line. You are done. Yes? It can be as easy as that. I want you guys to solve the absolute value inequalities, but all of these inequalities have a less than symbol, as you can see. The absolute value is less than or equal to 2, less than 5, less than or equal to -3. So, each one of these happens to work the exact same way. Please do that.
Yes, sir.
So what does it mean? Step number 1, or part 1, said just do what?
Drop the absolute.
Drop the absolute values, and you have half the problem. Then it's and drop the absolute value, right? Make it the opposite value and flip the sign.
Why we flip it?
Because it's like we're multiplying by -1.
I didn't. Hey, where's the name?
We change it from a 2 to a -2.
Oh, okay.
And solve them individually. Hey guys, guess what? This first initial parts of n minus 8 is the exact same thing, isn't it? So what I'll do to the left one, I'll have to do to the right one. Oh, that was the point, is solving. And so, plus 8, plus 8, plus 8, plus 8. N is less than or equal to 10, and n is greater than or equal to 6. Now wait a minute, let's think of this, guys. If I have to be less than 10 or equal to 10, and I also have to be greater than or equal to 6,
17.
isn't that just the same as 6 is less than or equal to n, which is less than or equal to 10?
Yeah.
You could have done this exact same thing, guys, of going, hey, if I were to drop the absolute values, I'd have this, but then make it larger or equal to the opposite of 2. If I wanted to get n by itself now, I'd just add 8, right? But But won't that lead to what we just did here?
Yes.
So there's a couple of ways we can do this, guys. So again, either one of those is correct, but I think the 6 is less than n, which is less than or equal to 10, is cleaner because I'm going to eventually have to graph it, right? And when I use this form, I already know my order of my numbers. 6 is on the left, 10's on the right. They're going to be what kind of dots?
No, they're not.
And I will shade between them. And you're done. I'd like you guys to try part B on your own, and we'll come together to finish that.
Okay.
Izzy.
Grab the value and then add, like, do the opposite.
You want to do the opposite first, or you mean the second one?
Like, you put the second one, and if you write the second one down.
Okay. So, and 2c minus 5
Is greater than negative 5.
greater than negative 5. Right? So it's not too bad. The next first step on everything is what, Eli?
Oh, add 5.
Add 5. Both sides. Whoops, over here. Add 5. Add 5. So we get 2c is less than 10. And 2c is greater than
0.
0. Caden, what's next?
You would
Divide
divide by 2.
by 2. So c is less than 5. And c is greater than 0. So that's one way to write this, guys. Or we could write this as a single compound inequality, which would be what, Hayden?
0 is less than C and 5 is greater. But yeah.
0 is less than c, which is less than 5. Open or close dots, guys?
Open.
Open. Oops, those are open. What am I doing? Open, open, shading. In the middle, it's all the values in between the 0 and the 5, not including them. Not too bad, right? We'll make room. So everybody shrink up your work and move it to the side. Guys, I'm going to keep the camera, the videos rolling right now. I'm giving you 10 seconds to count to give me an answer. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Answer? It's no solution.
Yes. I said it on 8.
No soul.
Why? How many people started breaking this thing up, guys? Emma, why is there no solution to this? Shh, listen.
If you solved it, it would be -1 is less than or equal to b, which is less than or equal to -7, and -7 can't be greater than -1. Why not?
Okay, so Emma actually went through the whole entire process, okay? So let's do this. B plus 4 is less than or equal to -3, and B plus 4 is greater than or equal to 3, yes?
Yep.
Okay, I subtract 4 all the way across, so B would be greater than or equal to or less than or equal to -7, and B would be greater than or equal to 1. No. -1. Is everybody okay with that? I did that kind of quick. But, okay, remember, this is an and problem. This is one of those situations that both things need to be satisfied. So let's graph it and find out where they overlap. Negative 7's there, negative 1's there. I think everybody would agree that they would be closed dots, yes?
Oh.
Where is b less than or equal to negative 7? It's going that way, isn't it?
Yeah.
Where is b greater than negative 1?
Oh.
Where do they overlap?
Nowhere.
They don't. So this is no solution.
No solution.
Okay, now, do we have to even go that far?
No.
Why can we just say no solution just by looking at this? That's not good enough. Lauren, what do you mean? You're right, because the 3 is negative, but why?
The way this process is set up, you have to change the number to a negative, but the numbers are negative. So then if you went through the process, then the other one would have to be positive.
Okay. I'm not going to take it as far as because it's already negative, because we'll turn it positive type thing. As the process, it doesn't always have to be a negative, I'll say. I think we got to back it up a little bit further than that, and don't even think about the switching of the forms. Someone give me the definition of absolute value again. No. Okay, what does absolute value do then? It makes it positive. Can you have a positive number at the end be less than or equal to a negative number?
No.
Therefore, no solution. Can you guys see that? If you can't be, by definition, less than a positive number, then you definitely can't be less than a negative. 0 is the smallest number you can go to, not a negative. Okay? Guys, I shouldn't have to give you any explanation. It's just that we're going to switch to greater than problems to use the other case. I would like you to solve part A. Go. Okay. What's the first step? Mark? Okay, so I get 2k plus 1 is greater than 7. Or what? (2k plus 1 is less than 7?
Yep.
Oh,
Negative 7.
negative 7. And now I'll just solve it, right? Subtract 1. (2k greater than 6? Or 2k less than negative 8? Guadalupe, what will we do next? So we divide everything by 2. So k is greater than 3, or k is less than negative 4. Negative 4, 3. Open or close dots, guys?
Open.
Open. Let's check the k greater than 3 side. If I put it in, actually I can just use negative 4. If I put negative 4, is negative 4 greater than 3? No. So therefore, I got a shade on the right side of 3. If I put in 3, because this point's over here, here at 4, k, is 3 less than negative 4? No. So I'm going to shade away. It's an or statement. They should go away from each other, right? Okay. Should. I can be that guy again and say I'll give you 10 seconds to do part B.
Do it. You already did that.
But but unfortunately this one's not a no solution.
So it's just really simple.
15 seconds.
Okay guys, try part B. Last problem. Guys, if we can't find the answer to this right away, then let's break it up. R minus 6 is greater than or equal to negative 5. Or R minus 6 is less than or equal to 5, right?
The same thing.
Same thing, so plus 6 plus 6.
They're equal.
R greater than or equal to 1. Or R is less than or equal to 11. So when I go to make this, close dots, yeah?
Yeah.
11 and 1. What side is 11 greater than or equal to 1? It is. So I got to shade towards this way. Is 1 less than 11?
Yeah. Yep.
Yeah, I'm going to change colors there. Then all of a sudden it means I got to shade this one this way.
It's not a second.
Yeah, this is not, guys, this is not an overlap problem. This is an if or an or problem, which is this one or that one. Well, guess what?
There's both.
Both of them overlap a little bit of each other, but each one is covering the other part that the person before didn't cover, yes? So the actual answer to this is all real solutions. All real solutions. But wait, guys, why is this true? The answer lies back up here. Definition of taking the absolute value of a number makes it, when will a positive number be greater than or equal to negative 5? Always.
Oh, yeah.
So be careful for the trick questions, guys. They may try to do that. Homework is worksheet 5.5. Have a great day.